What's up, DE students? We are going to be completing assignment 213, the first circuit, which you should have completed in multisim. This is its logical expression, A, C naught, or A naught, C, or A, B naught, C. We're going to turn this multisim implementation into a real-world implementation in TinkerCAD. I'm going to walk you through this process. You have never done this before. I'm going to go at a nice steady pace, so please pause the video when you need to. So eventually you're going to be doing another one of these on your own. So let's start by kind of thinking through the structure of this circuit. We have a series of inverters that flow through some AND gates that end with some OR gates. So we start with inverters, then ANDs, then ORs. This is the general way a sum of products expression will happen. So these are my inputs. This switch will control input A from 1 to 0. This switch will control input B from 1 to 0. This switch will control input C from 1 to 0. So to start, I'm going to put, once again, if we go look at multisim, we start with inverters. That's the first thing we need. So I'm going to go to all components, scroll down, and place an inverter chip. So I'm going to grab this hex inverter, and we're not going to have a ton of room in this assignment, so I'm going to put it pretty close. The first thing you should do anytime you place an IC is attach power and ground. So the power pin, I'm going to go to the positive column, the ground pin, I'm going to go to the negative column. You can see I have the negative columns connected together and the positive columns connected together. Okay, next we have some AND gates. So let's grab an AND, a quad AND gate. Let's put it, space it out just a hair. Okay. Power, ground. Let's do the same thing. Okay. And last, I need a chip to do these OR operations. So I'm going to grab this quad OR gate right here. Power, ground. By hovering over the pins of the chips, you can see what they do inside. But I also want to draw your attention to their pinout diagrams. So if you remember, inside, for instance, this 74LS08, inside there we have 4 AND gates. You can see here's my power pin, here's my ground pin. These pins on the bottom left-hand side, closest to the notch, will be the inputs of an AND gate. The output of that AND gate will come through pin 3. If I hover over the chip here, I see input 1A, input 1B, output 1. So there's a little AND gate in there, and then I have 3 other AND gates that I can use. So a total of 4 AND gates. If we go back and look at our multisim circuit, I have 4 AND gates in the circuit, therefore I can fit all of these on one chip, and I only have 2 OR gates, so that's going to be fine as well. Okay, the first thing I want to do is I need to make inversions of all 3 of my inputs. So that's A, B, and C. I use all of their inverted forms. Here's C naught, here's A naught, here's B naught. So this is my inverter. If we look at its pinout diagram right here, we can see that here's power and ground, because there's only one input, it's just sort of every other chip is an input and an output. So I can feed A into this circuit right here. Sorry, can feed A into here. So I'll grab A as purple. And now not A is going to come out of this output. And I can stick a little note there to remind myself of that. And we use a little tick mark for not A. There's another inverter gate right here. So I can grab B. Oops, very easy to do that. You notice how I kind of go around the holes so I don't block them. So I'm putting the B input into this input, and the output here will stand in for not B. last, I need to create not C. So I'll grab from here. Oh, that's the wrong blue. It's okay. Go into input 3. There we go. Now C naught is waiting at this pin right here. So now I have a place to grab all 6 of my possibilities. If I need A, I pull from this column. If I need A naught, I pull from this column. I know these are really rows because we've kind of flipped the breadboard, but we're going to think of them as columns. If I need B, I pull from this column. If I need B naught, I pull from this column. If I need C, I pull from here. If I need C naught, I pull from here. Okay, let's start plugging these correct inputs into our AND gates. So let's start with this top one right here. If I look carefully, this is a AND operation of A and C naught. Okay. So input 1, I want to be A. Now here's where, you can do the wiring however you think it looks nicest. Sometimes I'll kind of bounce around like this. I'm going to keep that purple because purple represents A. This needs to go to C naught. I've decided, you know what, I'm going to make C naught. Well, no, it's okay. So C naught, it comes from here. This one's a lot easier to grab. I'm going to make that the other blue color. I like to do kind of similar colors for an input and its complement. So like C is kind of this darker blue, so I'll make C naught the lighter blue. All right, so now we have created, remember there's a little AND gate in here. You can imagine it's like 2 little legs that come in, they go through an AND gate, and then they come out this leg right here. So to remind myself of that, I can put a note right here, and I can say this is A C naught. Waiting there. Okay, let's look at our next AND gate. It is A naught and C. Okay, I know where A naught is. It's right here. So once again, it starts to get pretty cluttered. You can use some of this space down here. Maybe I'll just go right there. So let's see, A is purple, so I'll make A naught pink. And then we've got, okay, A naught C. Okay, well, C is off of this row right here. Now there's a little trick, it's also right here because I brought it over to here. So I could pull it from here, but just to avoid confusion, I'll pull it from here. And we'll make that dark blue. A naught C. The output comes through there. A naught C. Put the tick mark before the letter that is being complemented. Okay, we've done 2 of our AND gates. We need to do 2 more. This AND gate, its legs are attached to A and B naught. All right. So where are the rest of our AND gates? Well, they kind of work backwards. You can sort of think of them, they go around like this. They skip the ground pin, and then they start up here. Well, sort of. If you look at the pinout, it frustrates people because they all flow to the right, sort of, if you have the notch on the left. So we'll use this one to make the next one. So here's input 3A, 3B, and there's output 3. Let's remind ourselves what I need. It's this AND gate right here. That's A and B naught. Okay, A and B naught. So we'll put A into here. I'm just going to grab it from right up here because this is also A. And then this needs to be B naught. Okay, you can actually draw underneath these chips, which makes it sometimes a little bit easier to move around where you need to go. Oops, let me redo that. Okay, I need this to be B naught. Mm, there's B naught right there. Put more. And we'll change that to, let's do yellow. It'll pair with green. Okay. A and B naught. Okay. And then that pin right there is representing A and B naught. Okay, last one. Believe it or not, we're very close to being done with this whole circuit. This is our last one. Ah, look at this. Okay. Okay, so one of its legs is coming from C. The other one is coming from the output we just had, A and B naught. Well, that means we need to take this output. Here's our last gate. Here's input, input, output. Let's look at the pinout. Input, input, output, 13, 12, 11. So we need to take this, that's A, not B, and we need to put it into the input of one of these. And I like to use like a brown or something for that. That's like a muddy color because it's multiple. It's already representing. It's already some colors being combined. Okay, so that's A, not B. This other input of this last AND gate comes from C, all right? So that would be this input right here. I need to pull from C. And I can grab C right there. And we'll make it blue. And then that means this leg, this last output leg, is A naught B C. AKA it is this expression right here. Wait a second. A B naught C. Right? Yes, yes. I just typed this in wrong. Did we do that right? Yeah, that's A. Okay, we're good. I just labeled it wrong. A B naught C. There we go. Okay, having fun, hopefully. If these things get in your way, you can make them a little bit smaller, but I really recommend having those labels on there. They make it way easier to trace when you have problems. Okay. All right, I got 2 minutes left in my recording. Let's look at our OR gates. This OR gate needs to combine, well, what is that? That's A, C naught, or that's our first two ANDs. A naught, oops, C. So I believe that's these two. So here's our first input. So I'll grab this one. We'll make that brown. And then I'll grab this one. So those are those first two ANDs, and then they're being ORed together right there. And I can already tell you that the output of this is going to go right into my next OR gate. So all I have to do is grab the output, put it into the input of the next OR gate. Remember, let's think about the pinout. This is what I did. I took this output and I stuck it into this input. Then this comes from this big one that we made right here, because that is the output of this gate right there. It needs to go into that second OR gate. So this other input, input 2B, or not 2B, needs to kind of snake its way up here and find that pin. Right? Yep. That's the output pin of that last AND gate. That OR gate, the output of that, goes to my LED. And hopefully nothing explodes. How do you test this out? Well, there should be combinations of minterms that work. So if it's A and not C, so if I have A on and C off, the light should be on no matter what B does. Okay? Or A is off and C is on, light's on. Or A, not B, C. A, not B, C. Lights on. I'm done. Woo! 2 seconds to spare.